Okay, welcome everyone to another VC Libraries video code review. Today we'll be looking at spanstream again. Last time we had reviewed everything except for the product code and the main test. And our contributor Misko has revised that PR in response to the feedback that I sent. So now it's time to take another look. So let me go ahead and share my screen. Here we go. Okay, great. So this is the PR we're looking at, PR 2029, implement P0448R4 spanstream. As usual, it's linked to our tracking issue that mentions the paper that was voted in, the feature test macro, and I just updated this. Casey has submitted change to the Visual Studio IDE that's part of our checklist whenever we add new headers. This is adding a new standard header, and it's extensionless. So he's taught the IDE to recognize it as a C++ header. So by the time that we merge this PR, the IDE will know to recognize this as C++, and you'll get the usual syntax highlighting and all that. We've also, that PR also teaches it about stack trace, even though we don't have that header yet. So here's the proposal that we looked at last time. And yeah, let me scroll here. Where is the wording? Yeah, technical specifications. I believe we looked at everything except for the the main header. So I'm going to open up the current working draft, which is 4892. And here is the wording as it was applied to the working paper. With the synopsis and everything. So I'm going to close. I don't think there's anything else in the paper beyond this new added section. I'm scrolling through real quick to see if there's any changes at the very end. No. Okay, so we can just look at the new section. That way we're not going to be caught off guard by changes that have been applied to the working paper after this was voted in. Editorial or library issues. Okay, so we can close this. Okay, so first, let's scroll through the conversation and see what has changed recently. So here's the review I submitted with our note to self that there's going to be checklist items we got to do when we actually merge this into the internal repo, setup authoring and things like that. But the VS part is done. So we've got changes to merge main, address review comments, and then fix build break or test failure. And now all the checks are passing again, which is good. Okay, so let's go here. I appreciate that Misko did the merge with main before anything else, because that will make it easy to look at just what's changed recently. So first I want to catch up on that. So I can click here on the changes from all commits part. And instead restrict it down to everything after, because I don't care about this merge. I'm going to, there's two different merges. Okay. Usually if I shift select, that will actually get the merge as well. Yeah, maybe that's fine. Okay, so I'm going to hold down shift, click once, click twice, and that will get everything except for that first merge that I don't care about. Okay, let's just see quickly what's happening. So part of this is to preemptively merge with a PR that is in flight right now, where we've decided to drop virtual and only say override, which is a new convention that we're going to follow, making it easier to see when we're introducing a new virtual function, because that will have to say virtual versus just an override. So to avoid stealth merge conflicts with newly added code, Misko is preemptively dropping virtual here, and that's good. But we've got override, which we definitely want on each site. Okay, and then, okay, so, and that's part of the header we haven't looked at yet. YVal's core H has changed. This is merging with main because we had accepted the providing size feedback in the allocator interface. So spanstream is being preserved in sorted order, but gaining angle brackets, which I believe I requested last time. That looks great. Similarly, for the feature test macro, merging has added allocate at least, reformatted scope enum due to claim format. And we've also got outputter, which we merged, and then spanstream is right below. That's actually unchanged. So that's all good. And it is still in sorted order. We've got removal of duplicate banner in the test. Good. We've got removal of this if defined CRT build that I commented on, because this is defined only when actually building the STL itself. Okay. I hope that this text is large enough to read. If not, let us know and I can zoom in. And then in main, this is being converted to a compile-only test. The test is also being renamed to test compile pass CPP, following our convention of saying int main compile only, and instead just making global objects of type test aliases, forward declarations care, and forward declarations WQRT, and then there's no need to void ignore them. Okay, that's good. In this test, remove duplicate banner. In the header units, as I requested, now actual code is being exercised, which is good. Let's make sure this is being added in sorted order, span followed by spanstream. Perfect. Okay, so this code is saying we put something just to see if the test crashes or anything. We can at least see very quickly in the log how much has exceeded. So we're testing spanstream. We have a modifiable array of char I buffer that's set to be initialized with a string literal of 1, 2, 3, 4, 5, null character. We get an I span stream with a span of modifiable char backed by this. We got an int red. We're counting from 1 through 5 inclusive. We assert that the stream is still good. We stream and read, and that we're going to expect to read 1, 2, 3, 4, 5, and then stop. Okay, that's good. We've got a string view, expected 10, 20, 30. We've got a char O buffer of size 10, which is more than enough. We've got a O span stream OS with a span of modifiable char O buffer. And we're streaming out 10, 20, 30 with no spaces. And then we assert that the begin and end of the O span stream span is equal to the begin and end of expected. That's good. And then finally, we have a plain span stream. We have a char buffer. We do the same streaming thing, and we assert. This doesn't turn around and use it for input, but that's fine. This is just the header units test. It's not an exhaustive test. We're just trying to make sure that instantiating some stuff works. The other thing that occurs to me is that with the ispan stream, here we have a modifiable buffer. We make a span of modifiable, but this is input, of course, so we're not actually going to modify the thing. Both of these things could be const. I do like const, but it is only test code, and yeah, the rest of the test is fairly disciplined about let's make things const when they don't have to be. I think the thing that tips the scales and makes me want to comment that this should be const is that it's interestingly different from the OSPAN and plain span stream stuff, which have the span of modifiable char. If we have const here, we're exercising span of const char, which is nice, but also making sure that this constructor accepts span of const char. And maybe, you never know, maybe a CV qualifier in there will interact with header units somehow. And that I buffer is not used by anything else. I think I'll request that. Let's see. This could be, or this array and span could be char. It doesn't really matter, but it's a slightly stricter test of I span stream and might exercise the compiler's header unit machinery in a slightly different way compared to the modifiable char buffers below. Okay. Almost nitpick level. Actually, it is nitpick, but I think it is worth commenting on. This array in span could be const-care. It doesn't really matter, but it's a slightly stricter test of spanstream and might exercise the compiler's header unit machinery in a slightly different way compared to the modifiable care buffers below. Okay. Oh, that reminds me, in the PR, I think there was an early comment. Let me see if I can open this up. For other cosmetic level things, and Misco asked me to make those changes. Yeah, from Adam Boussier when he reviewed the test said stood span everywhere. Oh no, sorry, this is in the product code. That's right. And the question was, could we just add a comment about avoiding ambiguity? So I can go ahead and do that. I'm assuming all the issues I find are superficial. I can add that. So I've left that unresolved as a reminder. Okay, so other than that, this change to the standard library header units test looks great. And in the include each header alone test, we're adding spanstream, and I do recall asking for this. I think I did. Okay, so that's good. Let's go back and look at all changes. Okay, let's Alt-click to minimize everything. Okay. Let me open up the list of files to change here. Okay, so let's make sure we got everything. So we've got the CMake list change. Actually, let me split this. Okay. Okay, so we got the CMake list change to add the new header. It's not a source, so we don't need to hack the legacy build system. We've got MSVC all public headers. Yep. We've got it mentioned in the header units JSON. Misco's added the include each header alone change as requested in sorted order. Yep. So that's now viewed. We've got changes to the custom format pi, custom build BHEL, and then the test CPP that we just reviewed, where we import and then we actually exercise it. Okay, so that's all of the changes in the GitHub repo needed when we add new files, and then we'll do the internal setup stuff. Okay, so that's great. Let's see what other files that need to be marked as viewed. YVL's core, we looked at this, the new header, the new feature test macro. This is a lot simpler to view as just a new change. SP comes before ST. Okay. Yep, sorted order. That's all good. We got the feature test macro test being added. This is the iOS forward where we had reviewed this last time, but this has now been converted to test compile. The duplicate banner has been removed, and the bottom of the file is now in main compile only. So this is all good. We looked at everything else there. So that can be marked as fully viewed. Okay, so that brings us down to just the product code and the test code. Okay, so now that we've caught up with Misco's latest changes, let's actually look at the product code. Okay, so we're starting off with a usual comment, spanstream standard header. And it's not a core header because it drags in tons of runtime machinery, of course. We got our license banner. We've got the usual system of pragmas and stuff. Let's see here. I can do a side-by-side comparison. It's been a while since we added a new header, so it's always nice to look. Let me open up Vector, which is the best header in the universe. Vector. Okay. Let's go to the top. Oh, there. Function key. Okay, so we start off with the comment, the banner. We got our pragma once. Here I'm checking to make sure that we've got all the incantations in the correct order. Pragma once, we got if and def define. Our convention is underscore, capital name of the header underscore. We include here, it's yvals h because this is non-core. We may as well just drag in the whole thing. It doesn't really matter in a non-core header if we drag in core or not. The verse matters. In a core header, you only want to drag in yvals core h, which is the minimal central header. If STL compiler preprocessor, yep, this guards the header from expansion when it's being processed by a non-compiler tool like the message compiler or Qt's mock, things like that. Then because this is a new header, we've got something a little bit different than vector. Our usual technique is if we're not underscore has CXX23, we emit a message. The contents of spanstream are available only with CS plus 23 or later. Okay, looks good. Else above, that's when not has CXX23, otherwise has CXX23 below. Okay. If def concepts, double underscore cplib concepts, of course. We include concepts, and then the rest of the headers, iStream, OStream, spanstream, buffx utility. Let's check the work and driver. Okay, so this header is not mandated to include anything, so there's no missing includes that we definitely need. So after our inclusions, back to verifying against vector. Push pack, push warn, disable clang, push new, undef new to guard against macrise new, the one evil thing that we guard against, and then stood begin. Okay, so the usual preamble looks good. Let's check the epilogue at the bottom. Control end. Okay, so we got pop new, restore clang, pop warn, pop pack. The end ifs in opposite order. We should expect to see 6623, compiler preprocessor, and then header guard. So endif underscore has 6623, endif underscore STL compiler preprocessor, endif underscore spanstream underscore. Okay, good. I always check these for typos, just in case something has not been properly copy pasted. And of course, we got the std in there. Okay, so the preamble is good. We try to make sure that these are always consistent, just so we don't get gradual divergence creeping in. Forgetting any one of these could lead to, oh, our headers are now binary incompatible if somebody compiles with ZP4, or we don't suppress warnings for clang, or we don't defend against macrise new, things like that. Okay, so thanks, vector. Now let's actually review the code. Okay, let's compare against the working paper here. That's good. That's a little bit wide. I know it's a little bit tiny. That's good enough for the synopsis. Okay, so let's take a look at this. Okay, so stood begin. Template on class underscore capta LM, class underscore capta traits. We got class basic span buff. That's this thing. We are missing a default template argument, but I believe that has appeared in iOS forward. iStream and OStream are definitely going to drag in iOS forward. Let's double check to make sure that iOS forward is providing the default args. Yeah, basic span. Okay, so all the default args are coming from here, and we cannot respecify a default argument. CS Plus will be quite unhappy with us if we try. So that's why it's not mentioned there. Let me double check to see that we follow this practice and we don't have a comment about the default arg in something like the basic file buff. I think we don't comment it in any way, but let me double check. File buff. Okay, so we've got iOS forward is going to declare it with the default arg. There it is. When we define it in fstream, we mention it without any default arg or even a comment. So this is exactly consistent with existing practice. Awesome. Okay, back to spanstream. Okay, so we got our basic span buff. Okay, and then we're immediately jumping into the definition. Let me switch. Is there a shortcut for that? Not that I know of. So we've got the basic span buff there. Okay, so here's the span buff. Okay. And we derive, it's a class publicly from the basic stream buff of LM traits. Yep. And the standard's called char-t. We've got public type defs. We've got an internal type def mysb, which is the stream buff. That's our base class. Okay. Then we've got using char type elem, using int type. We reach into the traits and we say, use that int type, use that pos type, use that off type, using traits type traits. Okay, so this is all good. Okay, so now we got some constructors. Misco has stable name comments here. Oh, that's actually in the definitions. We can just checking the stable name real quick. Yep, span buff.ctor. Okay, so we've got a default ctor that's defaulted. This depicts delegate to the basic span buff constructor that takes an open mode, initialize with an empty span and in pipe out. Then that is going to store them here. So if this is being equals defaulted, we need to look at the data members. Let's take a look at that. Okay, so the data members, we've got the IOSpace open mode, exposition only underscore capital mode, defaults to IOSpace in, pipe IOSpace out. Okay, that's correct. We got a std span of elem underscore capital buff. That is value initialized. Okay, so defaulting the constructor, while not what is depicted in the standard, exactly implements what's in the standard, so that's good. Okay, so that's good. Now we've got an explicit constructor. Explicit, and here I'm mentally running through, okay, do we need like, no discard or const expr or template or anything, and not on these constructors. We got an explicit basic span buff, take an IOSpace open mode underscore capital which, that instead of delegating, which involves like additional function calls and code gen, Misco here is directly initializing members. So the base class gets initialized with nothing. The mode gets initialized with which, and then the span buff is initialized with nothing, which is what the standard depicts here. So that's all good. That's optimal code gen. And it's not really more complicated. It's a slight difference from the standard, but that's totally okay. Next up, we got an explicit basic span buff constructor taking a std span of elem underscore capital span. We got an IOSpace open mode underscore capital which is in pipe out. So one thing that occurs to me is that these things could be const. This one, it doesn't really matter. And we are not 100% disciplined about const. The more complicated a function is, the more I want to see things being marked top level const, because that gives me confidence that things aren't going to be modified accidentally. And it makes it more obvious when we actually do plan to modify a data member. In this case, this function is large enough, although it's not really, it doesn't really read which at all, it just stores it. Then it starts looking at the data member mode. I kind of would like const here. It's not absolutely critical. I'm tempted to not comment on it. If I see more occurrences of this, I'll come back and I'll say, let's just add top level const everywhere. I'm fine with this. Maybe it's not super consistent.
We have a question in the chat.
Yeah, go ahead.
Why are the uses? Why is the reference to span std qualified here?
That's an excellent question, and this is actually what Adam Bussier had asked in his review. This is also something notable because we have this convention of let's not qualify things unless we absolutely have to, like non-ugly function calls we qualify with std to avoid argument-dependent lookup. But everywhere else we can, when we mention a type or an alias template or a variable template, or even a non or even an ugly function that's internal, we avoid the std qualifier to have readable code. So it's very unusual to see std span here because we are within namespace std and there's no opportunity for argument-dependent lookup. The reason why is because basic span buff has a member function that is named span. It's down here. So mentioning span could be ambiguous. Do you mean the member function or do you mean the non-member class template in namespace std? So there's a bunch of arcane rules in the standard that I can literally never remember about exactly how identifiers are looked up in a class. There are some places where it is not ambiguous to mention the class. I think it's you're outside a member function, the class is parsed from the top down. So you can mention something that has not yet been seen. Maybe it's the other way around. To avoid confusion, to avoid having to know those rules, the convention that we follow is, or that we try to follow, is that when we have this relatively unusual situation where we have a member function that is named the same as something in namespace std that we'd like to use, we just always qualify the ones from namespace std. Even if they may technically be unnecessary in some cases, it's just visually clear what refers to what. The other places I can remember where this happens in the STL are path. In the file system header, there are some member functions named path that shadow the actual class std file system path, and reverse iterator. Many containers have typedefs reverse iterator that are exactly the same name as the std reverse iterator. So we will often qualify std reverse iterator just to avoid any ambiguity, even if it's not technically necessary. I think there are actually a couple cases where we don't qualify, where we probably could to be consistent. We're not like 100% there. I can actually see reverse iterator. Hash map is non-standard, so let's ignore that. Okay, so here's a good example. Here we've got the std array using reverse iterator typedef, and then we have to say std reverse iterator angle bracket iterator just for clarity. I think that this particular case may be one where we could drop the std on the very first mention, but afterwards we definitely would need to keep saying it. Otherwise, the language would say, "Oh, you mean the typedef, right? Not the non-member class." And here we're actually using the typedef, so we don't qualify it. So that's what's going on there. And the resolution of the comment from Misko talking to Adam Bussior is that we should probably just comment this once in the header. Possibly a good place is maybe at the top, just so somebody reading basic span buff from the top down sees, std span is distinguished from the member function span. Great question. Thanks for noticing. You can also notice in the standard, it also qualifies std span, even in cases where it might not technically be necessary, just to avoid any confusion. Oh, and I am accidentally highlighting it. That's fine. Okay, so back to this constructor. I was thinking about const qualifying this. Let me just scroll down a little bit, see if this occurs. Yeah, there's probably a lot of other cases where we could add top level const to like this span. We're not actually modifying the span. There's a lot of them. There's like off. This can always be cleaned up later. I'm not going to comment just because it affects a lot. It's relatively low value. Whereas with like the header units test, I was like, okay, it's literally 2 lines. Let's just do it. Here we know the whole library needs more attention to top level const. I think that can go unremarked. Okay. So this constructor is doing a bunch of stuff. Let's look at the definition of that down here. Okay, so initializes the base class with empty parens and mode with which we're doing. It sets the internal pointers as if calling span of s. So why are we doing all that stuff? Span taking, okay, so span taking s does a bunch of stuff here, which I'm assuming maps to this. Why do we repeat this rather than just calling the member function? I'm assuming the member function is going to do something. Yeah. It's possible Misko is essentially inlined this for debug cogen, but this is complicated enough that I think I'd prefer to see just the member function being called. Let me diff these to see if there's anything interestingly different between the two. So this is the member function. We can de-indent that one. And this is the constructor. Can also de-indent. Yeah, that's the same level indentation. That looks very visually similar, but let's double check. Let's select these, right click, compare selected. Okay, their guts are literally the same. This one initializes buff with span, this one assigns buff to span, and then runs this exact same code. I would kind of prefer, I think I'd really, just to avoid code duplication, to follow what the standard depicts. And if we care about debug code gen, we could gain all of it back and more by extracting these calls to data and size, because every single one of these is an actual function call in debug mode. And they're not changing during here. Let me suggest that. Okay, so this, let me get the citation. Constructor initializes term pointers as if calling span s. Okay, so I want to comment on the mem initializer list down to here. Okay, so this constructor body is duplicating the implementation of, I'll say dot to make it clear it's a member function, dot span s. I think it would be simpler to simply call, to simply initialize, it's the data member name, underscore capital buff, underscore buff with empty parens, and then call the span s consistent dot span s member function as depicted in what are you, span buff ctor 1. Span buff ctor /1. There will be a minor debug code gen cost, but I think that avoiding code duplication is more important here. Okay, let's read that. Okay, am I commenting on the right place? First, no, I'm scrolling too much. Here we go. This constructor body is duplicating the implementation of .span s. I think it would be simpler to simply initialize underscore capital buff prime paren and then call the .span s member function as depicted in span buff ctor /1. There will be a minor debug code gen cost, but I think that avoiding code duplication is more important here. Now it occurs to me that these dots are kind of confusing. Let me just drop those. It's clear it's a function. Okay. Then I'll make the comment about extracting data and size below. And so we'll ultimately have a net win on debug code gen. Okay, onward. So we've got this constructor. And up here, we've got this one. We've got the defaults, right? Oh, no, just one default. Underscore capital which is in pipe out, yes. Okay. Now we've got a movable only type. So the copy ctor is deleted, that's right. Then we've got a move ctor taking underscore capital right. And what's that doing? It's going to be defined down here. Initializes the base class with std_move RHS. Yep, we got that. And mode with std_move RHS mode. This is redundant because it's an open mode, but the standard depicts it, so why not? And then buff with move RHS buff, also redundant because it's a span. There's nothing to steal, but the standard says so. We could drop the moves. It would be slightly higher throughput and slightly better debug code gen, but then it has scary looking divergence with the standard. I'm fine with this unless a user says that it's harmful. It all optimizes away in release modes. That's the important part. The sequence pointers in DRF this obtain the values with RHS had. I'm assuming that is what the MySB move construction does. Its implementation defined whether RHS buff empty returns true after this move. So MISCO is not clearing out the right buff. So our implementation is saying that is not being emptied. but we are nulling out the IOStream pointers of _right. The post conditions are that the state has been transferred, so we've got all that. It seems unusual that, I mean, it is an implementation defined choice. That we null out these, but we don't set the right buff to empty or to an empty span. I'm a little tempted to say we should define our implementation to make the RHS buff empty. We do provide this guarantee elsewhere. Our stood function provides a guarantee beyond the standard that move from functions are empty because users expected it. I doubt it will come up here. This is not nearly as fundamental type as stood function. I think maybe I'll just add a comment to ask. Should we null out or empty out the right span? We comment on the whole constructor. The standard says that it's implementation defined whether, let me get this, RHS, I'm not going to bother trying to italicize this, buff dot empty is true after the move. We've provided a let's say it's not non-standard, guarantee beyond the standard that move from functions are empty because guaranteeing that is, let's say, very cheap. That would seem reasonable to empty the right span here. Should we do so? Okay, let's double check this. The standard says that it's implementation defined whether RHS buff empty is true after the move. We've provided, sorry about that, maximize. We've provided a guarantee beyond the standard that move from functions are empty because guaranteeing that is very cheap. It would seem reasonable to empty the right span here. Should we do so? Okay. I'm okay with the answer being no, but I just like to double check that. Okay, so the base class is doing all this stuff. Now you double check. I don't actually know how basic stream buff works. Okay, basic stream buff. Where does this live? Stream buff header. Surprising. What does the move constructor do? Oh, it's a copy constructor here. Oh man, it allocates memory. Stream buffs. We knew up a locale and we transfer the contents of the right locale. We call it in a function. We set a bunch of pointers. Yeah, this is very expensive. So emptying out the right span is just assigns a couple, null pointer and 0. Ridiculously cheap in comparison. So I'm further confident that that's the right thing to do. Maybe I'll even edit my comment. But yeah, all that state is being transferred, so that's good. Let me edit this. I note that basic stream buff I'll say construction is very expensive. So the additional cost of zeroing out the span will be unobservable. Okay. Okay, assignment and swap. We are not copy assignable. So basic span buff ref, op equal, const ref is delete. Yep. The move assign underscore capital right. Yep. We have a non-ugly identifier. We have a non-qualified move. This needs to change. Underscore temp should be ugly. And move should be stood qualified. This code is too readable. It must be significantly less readable. Let us follow. Okay, so this is exactly what was depicted in the standard. Let's have a basic span buff with the injected class name temp, brace initialized from stood move of the right. Call this arrow swap temp from the base class, hence the this arrow, and then return DRF this. Actually, oh no, this arrow swap is that's a call to the member function in our class. Here, I think that this arrow is technically unnecessary because member lookup will find the member function and never consider ADL. But because the standard depicts this arrow, I think the simplest thing is to just literally say that. Because it says it's got the magic words effects equivalent to, which just says do what we say. So I'm fine with that. Again, then we return to this. Okay, so that's all good. Now we got a swap. Let me double check for notice cards. So we've got through the constructors, we've got through the assignment. Now we're getting into other functions. Swap returns void, of course. Oh, but we are going to have some notice card below. Okay, I was getting the sense in my head that, oh man, aren't we getting to the part where we should care about notice card? Fortunately, there's no like const-x for other stuff, and none of this is being no except strengthened, so that's fine. Well, down here we got some guaranteed no except. Okay, so let's look at swap. Void swap, taking basic span buff ref underscore capital right. Effects equivalent to call use our mysb type def double colon swap with right. Called stood swap mode right mode, stood swap buff right buff. Okay, so that's all good. And this is not no except because the base class one isn't. We've got a non-member function here. Let's scroll down and see if we can find it. Okay, here it is. Template class underscore kept lm, class underscore kept traits, void swap, basic span buff, lm traits ref underscore kept left, basic span buff, lm traits ref underscore kept right, effects equivalent to left dot swap right. Okay, so that's good. Okay, let's go back. Okay, swap. Now we're in the span buff members member functions. This is following the convention that we saw in optional and variant where different regions of the class are commented with stable names. We've got another PR that's removing all those. I'm fine with keeping these. They could also be eliminated, but they're not really harmful. Span buff.members. Okay, so we've got returning a stood span of elem called span. It's const guaranteed no except. This thing only lives to return the span. So this should be no discard. This observer should be underscore no discard. Okay. Okay, now we're following the returns. If IOSpace out is set in mode, so if mode single amper IOSpace out, here this is testing technically an integer for or enum or whatever this is, bitmask type for non-zeroness directly. We do this in a bunch of places in the STL. If something is literally an integer, I always prefer to see things being ampersand tested to compare against zero explicitly. But if it's a bitmask type and we're not in a complicated expression, I'm basically fine with this. So that's fine. Okay, so if we're in out mode, not exactly out, but just if the out bit is turned on, returns a stood span of char t constructed from pbase and pputter. This is making a temporary. We conventionally use braces here. I'll ask for that. It would be nice to construct this temporary span with braces for consistency with our modern convention. We try to use braces in new code. Certainly none of the old code doesn't uniformly follow that. But when you see braces, you know it's not a function call, which is nice. There's only a few places where we can't use braces because either the standard implies that we can't, it has observable effects, that sort of thing. Or there's like an initializerless constructor that competes. Okay, so should be no discard, should use braces. Otherwise, yeah, p-base, p-putter. Otherwise returns buff. Okay, looks good. And these are qualified because they are in a dependent base. And I believe we conventionally say -b double colon to get those rather than this arrow and the other stream buffers. Okay, so now we've got the setter. Why is kind of rendering flawed there? Okay. Void span, so no discard. Taking a std span of LM underscore capital span. The span is not const, but there's no real danger of accidentally modifying it, so that's fine. It's guaranteed no except effects. Buff, assign S. Okay, this is what we saw in the constructor. Initialize the input and output sequences according to mode. So that's what this is doing. Let's make sure this all maps. If IOSpace out is set in mode, okay, then how do these differ? These differ a little. Okay, so p-base is S data. I believe that's this one. And EP-putter is p-base plus S size. Oh, these don't correspond exactly. Man, I don't actually know the order in which these things go. I'm assuming the test would totally fail if these were damaged. In addition, if IOSpace at end is set in mode, p-putter is p-base plus S size is true. Otherwise, p-putter is p-base. Okay, so the p-putter is varying between p-base and p-base plus S size. That's got to be the middle arg. That's why it wasn't corresponding. Otherwise, the first and the final args are the same. Okay, so that looks good. I really should double check. I know if I skip over it, I'm being a bad kitty. What is that? Set P? I don't want to look through the standard. CPP reference. Set P basic stream buff. Okay. Okay, slightly more readable than the standard. Okay, so we've got, it takes, we want the 3-arg version. We don't want the 2-arg version. Yeah, I'm looking at 3 args here. Why is this only 2? Okay, I'm clearly missing something. Let's actually look at the standard. Okay, we were in spam of virtuals. IO streams. Stream buffers. I believe it's protected. It's put area, get P, is that right? There's only 2 args. What am I missing here? These are clearly passing 3 args. Set P. Is this a non-standard extension that we have? Okay, so let's check set P. We need whole word. Stream buff. We got 2. We got 3. Okay, so we do have a 3-arg version. Is this an extension? Yeah, it's an extension. Okay, so that's what's going on here. I was like, this is impossible. Why do we have an impossible function call here? This one will set IP first, IP next to something different if necessary, and then last. Okay, so really we should get rid of this in vnext, but it's so convenient to call, so that's why it exists. And that's why that middle one, the IP next, is being, it's changeable there. Okay. Yay for non-standard extensions, not. And so that is, okay, let's go back to the span buff. It's down to virtuals. Okay, so we got the set P there. That's seek off. We don't want to get down there yet. Yeah, okay, so that's where that's coming from. And then if in is set in mode, and this is not an else, so it has to be a separate test. That's why we've got a new line between these if statements. They're not chained, makes it very clear that it's independent. If IO space in is set in mode, this is in the G, the get area. eBack is this data. gputter is also eBack, so S data again, and then egputter is eBack plus S size. Okay, that looks good. But I was going to comment that these could be lifted out. That's a lot of calls. The numerous calls to buff.data and buff.size could be extracted into named variables, which would be better for debug, code gen, and debugging. It'd also make the code slightly more readable. In addition to improving ability. Okay, let's double check this. Oh no, I don't want to scroll down. Here we go. The numerous calls to buff data and buff size could be extracted into named variables, which would be better for debug code gen and debugging, in addition to improving readability somewhat. Most I'm thinking of, like, if we ever have to debug through this, having to hit F11, shift F11 to get in and then out of each of these member functions is extremely annoying. Even though we only end up taking one branch of these, we do call data 3 times and size twice. And then if we're in mode, we also call it a bunch. So extracting is definitely a win. It's well over 3 calls. Okay, so that's the span setter. So that's good. We look at the swap, getter setter. Okay, so then we got some protected overrides. We already saw Misco remove the virtual and has kept only override, which is also being depicted in the standard. Okay, so we should have set buff, seek off, seek pause. He's defining them in out of order. But seek pause is calling seek off above. Okay, so that's fine. Then we don't need to strictly follow the standard order here. Let's go down. Okay, so let's read. What is this enormous thing? Seek off. Oh, interesting. The declaration order in the signature does not follow the definition, and Misco is following the definition order here. That's cool. So these are protected. Okay. Okay. Note about not providing overflow, underflow, or p-back fail. Okay. So what do we have here? Turn pause type. Now, because this is a virtual, we need this explicit calling convention, just in case the user is compiling this to you with a different default calling convention for member functions. That happens in CLR managed mode. Yeah, that's an interesting question. Don't we? This is CS plus 23. Didn't we block CLR in, I want to say 20? Not CLR pure, which I think is only, we blocked CLR pure at some point as well. Earlier than CLR. Let me double check. Oh, I don't even have 2022 installed on this machine yet, but that's okay. We don't need it. We just need 1610. That actually works. Okay. This is tiny. Can I open up a terminal? Yes, better. This is x64. That's fine. So we've got our meow here. Let's compile this. Native first. Don't need to run it. Oh, and of course I wanted to test standard mode. Okay. So what does CLR say? CS plus CLI does not support CS plus versions newer than CS plus 17. So it downgrades to 17. We don't need to worry about CLI in 20 mode, much less 23. And that's even before considering CLR pure. So that's interesting. That means we don't technically need that CLR or this called macro, because that expands to, it's actually this macro here. Is this definition in the STL or is it in VC run? Oh my God, that's so many. Let me, actually, I probably don't even need regex. I just need pound define for the definition. Okay, it's not here. It must be in VC runtime. Let me, can actually find it. See, this is 2019, so it's still an x86. Visual Studio 2019 community VC tools MSVC 14 include. Okay. Actually, I can just CD here. CD paste. Find stir for CLR or this call. Okay, it's in VC runtime H. That's what I thought. Which will eventually be part of the GitHub repo. It just is not at the moment. Oh, one moment. Okay, sorry about that. Okay, so we're looking at CLR or this call, which is defined here. And oh, this is actually, it's not even plain managed. It's if we're CLR pure, or we're compiling the MERT DLL, it's CLR or it's nothing. So I'm like 99.9% sure this will expand to literally nothing for native code. Okay. So the question is, do we need this here? Did we do this for SyncStream? Because SyncStream is also 20, and this is 23 here. Let's check what SyncStream did. I think it overrode because we had a sync buff. Oh, we're looking for, okay. And what was that function? I'm not remembering. Seek off. It would say override as well. That's a new. Okay, overflow is an existing one, and we didn't qualify it here or give it an explicit calling convention. Whereas elsewhere, I'm pretty sure we do. Let's check that. In a regex. Yeah, so wherever, and this is going to be changed to drop that virtual, we do have CLR this call in fstream and in the deprecated stir stream, but not in the new sync stream. So it would be consistent with sync stream's practice to not bother with CLR or this call. It is necessary here to survive /CLR. So let me comment on that. I'm assuming this is going to, yes, occurs below. Okay. Let's see. The occurrences of CLR this call in this file can be dropped. CLR is incompatible with CS plus 20 and CS plus 23, so we can assume we're always compiling native code where this expands to nothing. Sync stream overrode past tense. What was that? Overflow? Yeah, overflow. I could get the exact line on GitHub, but that would take a little bit. Overrode overflow without this explicit calling convention, unlike fstream and stirstream, where it is definitely necessary, occurs below. Let me say, so omitting it here would be consistent with that new practice. The explicit calling convention is necessary for older code to ensure that the virtual member function exactly matches the base class. Okay, complicated topic, but let's see if that summarizes it properly. The occurrences of CLR this call in this file can be dropped. CLR is incompatible with C plus 20 and CS plus 23, so we can assume we're always compiling native code where this expands to nothing. Sync stream overrode overflow without this explicit calling convention, unlike fstream and stirstream, where it's definitely necessary. So omitting it here would be consistent with that new practice. The explicit calling convention is necessary for older code to ensure that the virtual member function exactly matches the base class, occurs below. Okay. Okay. Okay, let's compare the signature now. Okay, and this is the sync stream that I'm looking at. I want to look at the standard up like this. Okay. Okay, this is a big member function. Span buff dot virtuals, overridden virtual functions, pause type, seek off, taking, and this is side effects, so definitely no discard. Taking off type off, verifying ugly here. IOSpace seekter underscore capital way, IOSpace open mode underscore capital which is in pipe out override. Okay, alters the stream position if follow, so he's extracting some tests. Const-bool are we underscore capital sequence in is which and IOSpace in. Yep. Const-bool sequence out is which and IOSpace out. Yep. And then we switch on way because that's the incoming seekter. Okay. Case begin. Okay, if IOSpace in is set in which, why is it switching immediately? There's a lot of logic here. Begin followed by end. Guess it's testing sequence in, sequence out. Okay, there's been, let me zoom out a bit. There's been significant refactoring from what the standard says here. It looks like the standard starts talking about in and out, and then switches on the way. And then here we're lifting that out to a top level switch. I find that confusing just because it doesn't one-to-one match the standard. And IOStreams has never, the wording doesn't sing to me. So, okay, alters the stream position within one or both of the controlled sequences if possible as follows. If IOSpace in is set to in which sequence in positions the input sequence x next is gput or xbeg is gback. Are we doing that? I don't see, I'm not seeing where this is happening. The correspondence to the code is not obvious to me. Okay, if both outspace in and outspace out are set in which, so for sequence in and sequence out, I saw this here, and way is outspace cur, the positioning operation fails. So we do have this here. If we're both in and out, and way is outspace cur, the position operation fails. Return pos type of off type of -1. These are technically C-style cast, but I think that is consistent with what we do elsewhere. It's like the one remaining case of a pos type paren. Yeah, we do that. Yeah, we do that tons elsewhere. Should maybe change that someday, but consistent with what we got right now. Okay, so that part I can see. We've got an if return. I guess it's fine to be represented as if, else. We could break the control flow after if return. That'd just make it longer. It wouldn't really increase clarity. Okay. Returns pos type, off type -1 if positioning operation fails, pos type move off otherwise. Okay, so we got that there. Okay, for sequence to be positioned, if its next pointer x next is null pointer and the new offset compute below is non-zero, the position operation fails. Otherwise, function terms base office type value type off type as follows. Okay, so 0 when way is the beginning. Okay, that's what this comment is talking about. Base off is 0. Okay, so this is doing some of these tests here. If off is a size t is greater than buff size, optimization comment negative wraparound to positive to save a compare because a negative off would become a large size t. So if off is just bigger or if off is negative, is that right? If off is any negative, we get huge. If off is strictly larger and positive, that fails. And the base offset is 0 when it's beginning. So we're just strictly comparing off. So if off would overflow, yeah, that's a negative case. Or overflow would be impossible here. Or if off is less than 0, and yeah, less than 0 wraps around a negative. Or if off is strictly greater than buff size, yes, the positioning operation fails. Okay, so we've got this. This test corresponds to this for the beginning case only. Okay, so that's good. We've got this part done. This is the overflow check. If off greater buff size, return, report fail, otherwise break. These braces are not necessary here because we're not introducing new variables. These braces for iOS, let's say case, iOS base beginning are unnecessary as no variable is being introduced here. We only conventionally add braces to cases when we introduce variables. Okay, so in the case of end, here, then for 3, that is the section, the base off is, okay, constant auto underscore kept base off is, and here we do need the braces because it is a new variable. If the mode is out, Oh, okay. That's like mode versus which. Are these the same? These are not the same for the non-constructors. So sequence in and sequence out tracks the which parameter. But mode is our expositionally data member. So we need to not get confused about these. Okay, so if IOSpace out is set in mode, this is testing. This really needs parentheses. This is mixing bitwise operation with logical operation. I can never remember who's got higher precedence. I think it is bitwise. This definitely needs parentheses for our convention. Question is, does it also need a comparison not equals 0? Let's see, how would I search for this in our code base? It would look something like space followed by and. Do we ever do this? Regex is willing to do a bitwise and comparison and then chain that with a logical and. It does it all over the place. String streams are also very willing to do this, as long as we use a logical operator there. Otherwise, it's a huge hazard. Okay, so I'll just ask for parentheses. Okay, here's a good example. Just ask parentheses, even though I personally would probably write it as a not equal 0. We just need parentheses here. This is mixing bitwise and logical operators. So we conventionally use parentheses to disambiguate the notoriously confusing for humans precedence. I want parentheses here. Okay. This is mixing bitwise and logical operators. So we conventionally use parentheses to disambiguate the notoriously confusing for humans precedence, paren, mode, and IOSpace out. Okay. So if IOSpace out is set in mode and IOSpace in is not set in mode, so if mode and out, sorry, I should pronounce this better. Mode, bitwise and IOSpace out, logical and, not mode, bitwise and IOSpace in. Okay, so that's all good. Then it should be the p-putter minus p-base static cast to the off type. Otherwise, it should be buff size. Okay, so that's the base off. Wow, we're just adding it. So this is an off type. What is off? Oh, off is a parameter. Okay, so we're actually modifying the parameter in place. Is off type signed or unsigned? You would think I would know this, but I don't. Off type. It comes from the traits. Is that a care traits? That's care traits. Care traits is. Probably put an X string. Oh yeah, here it is. Off type is the stream off. Okay.
It's signed.
It's signed. Okay, yeah, it's long. Okay, thanks, Casey. So that's concerning. We got a signed value here, and then we just add it. And then this asks, this will check negative, but if we literally overflowed, we just did signed integer overflow. And that is a case that's mentioned here. I'm not comfortable with this. I want to see a strict check for overflow before we even perform the operation. The rest of this is fine. This says, if then it ends up being less than 0 or strictly greater than buff size, we fail. But there's no overflow check here. Off and base off are signed long. So this is performing addition. It's actually signed addition without an overflow check. If base off plus off would overflow is the first thing we need to check. Now, maybe it's long, so overflow is unlikely, but I don't understand iostreams well enough to know if we can hit this without actually allocating 2 to the 63 bytes of RAM. I would be much more comfortable seeing an actual overflow check here. Off plus base off are signed long, so this is performing signed addition without an overflow check. Base off plus off would overflow is the first thing we need to check, period. Okay, otherwise we got that. If return break, okay. And then for current, okay, so we've already modified off there. So that actually has a side effect. Otherwise, the function computes new off as base off plus off. Okay, so it's just computing new off there. And it's accumulating it in off. So it's new off is going to just be off after this. Okay, so that's what's coming out of this switch statement. I'm trying to understand how what's the control flow and what's the data flow. Okay, so that is cur. So end, or sorry, that was just scrolling. That was end. Now here's cur. Okay. Okay, again, unnecessary parentheses. No variables here at the top level. Necessary parens for the case ios base cur 2. Okay, so for current, this one, the standards mode of exposition here, it puts the, when way is blah at the end, which I find excruciating. It should be at the beginning, like a switch. Okay, so cur, here's the in, out. Oh yeah, this is the one that I originally saw. Okay, so that's, where is it? I just saw it. Oh, it's the one that I highlighted. If in and out are set in which and way is cur, then positioning fails. Okay, that's the failure. Otherwise, for cur, okay, we can't be both in and out, but if we are either of them, okay, so I see Misko's unifying the logic here. If we're in input sequence, then it's the gputter minus eback. If it's the output sequence, then it is pputter minus pbase, and we're going to call that old off. Okay, so that's old off, which is actually base off, according to this here. Old left. Okay, this looks like an overflow check coming up. Old left is, okay, so this is making sure we don't exceed buff size. The buff size minus old off. I think this subtraction is okay because the offset is always going to be within the buffer as a class precondition or class invariant. Okay, so if the offset that we're going to add, we could add something as negative as negative old off. That would completely annihilate it and reset us back to 0. But if it's more negative than that, then that would be becoming less than 0. That would be bad. Or if the offset that we're going to add is greater than the remaining space, we could add exactly the remaining space, and that would take us exactly to buff size. But any greater, that would be that third case, or it could be overflow as well. So this will avoid overflow. And this is not computing an overflow itself because we've calculated old left in terms of the space we actually have remaining, which is safe to compute. So this is a good overflow check. I like this. We do the check, and then we do the addition. I just want to see the same structure here. I can actually edit this to say cur is doing the right thing. In contrast, the logic for IO space Docker is very strict about checking for overflow and out of bounds before performing the addition. Okay. Good. Okay, so we've got that. We've updated old auth. If neither are set, then report failure. I'm trying to figure out like where's that mandated? Where if neither is set, it fails. I'm assuming having a span buff where you're not input or output, that's bizarre. Why would you ever have that? I think failure is fine, even though I don't see it in the code here or the standards. Otherwise, we break. And then the default, we just always fail. Okay, if we're in some weird mode, that's impossible. Okay. Okay, so we have done, I think, this. Although no, we haven't quite tested this. We've got otherwise the function determines base off as begin, current, or end. We saw this. We saw the check. Okay. And we've computed new off into off. So we've got that for each case. That's either this plus equal, or the first one is adding 0. So you can just leave off unchanged. Okay, so now we're down here. It's quoting paragraph 4. Oh, something that's missing. This is quoting a specific paragraph, but it's not mentioning a working paper. This can get out of date the moment that a new paragraph is added. So when just citing a stable name, it's fine to have that be free floating, but when we are citing a paragraph, we need to cite the paper number as well to do archaeology if they ever renumber these paragraphs. Is that the first time? That's me. Okay, it's all these citations. Comment here. All of the citations to specific paragraphs need to be qualified with N4892 in case the paragraphs are renumbered in the future. Occurs repeatedly below. I just searched for square bracket slash. Mentions of stable names alone are fine when unqualified. Okay. Yeah, I try to remember that because I've read like the compiler sources, which will cite, the ANSI C standard from like, 1992 or something, some draft, and you're like, whoa, I have no idea what this is. Or same with, the old versions of the CS Plus standard. Okay. Yes, maintainers in, 2042 or whatever, you're welcome. Okay, so we're trying to find where we are. Okay, so paragraph 4. For a sequence to be positioned, if its next pointer, okay, he's not quoting it directly, but that's fine. For a sequence to be positioned, if its next pointer is a null pointer and new off is not equal to 0, the positioning operation fails. I can't let the grammar pass. Should say not equal to. I know this isn't a literal quote, but the grammar should be correct. Okay, so is this doing that test? If the next pointer is a null pointer, okay, here it's testing the pointers for nullness by negating them. Okay, so that's what's happening there. So it's saying if the new offset, the new one is now updated off, if that's not equal to 0, and we have a null pointer. When do we have a null pointer? It's if we have sequence in, then we look at the get area putter, and if that's null, we have a null pointer there. Or if we have the out sequence and the put pointer is null, then we have null pointer there. And if we happen to be in or out, then both of them had better be non-null. And we've actually already failed, I think, for the in and out case, but this is good as a very safe check. Then we fail. This one doesn't comment report fail. All the other ones do. That seems inconsistent. It's probably overkill, but the inconsistency should be noted. All of the other failure returns have the comment report failure. On the one hand, it's kind of like, plus psi increment I, but on the other hand, it's IO streams. I lean in the direction of getting a little bit more comments rather than less. And it's certainly good for consistency within this file. Okay, so this check has now happened. So we're slowly untangling the restructuring that happened here. And then assigns the x begin, which is the relevant pointer. It's either eBack or pbase. And so that's what these conditions are happening here. Plus the new off, which is just off to the next pointer x next. Okay, so this is being phrased as let's bump the get area or the put area by the remaining amount needed. So instead of assigning the beginning plus new off, let's adjust the x next by this much. So, okay, so I actually understand what's happening here. My stream buff G bump, the get area E back, that corresponds up there, or my stream buff P bump, the off minus the P putter minus P base. Okay. And then succeed pos type off. Okay, wow, that was a big function, but I believe I understand everything that's going on there, so that's good. Guess that's done. I think we can finish these other two virtuals, then we'll be at the end of this class and our time for today. And next up, I'll have to review basic spanstream offline, or iSpanstream. So let's look at these virtuals. We got seek pause. We've already commented on the explicit calling convention. These all have side effects, so definitely no discard. Pause type, seek pause. Take a pause type underscore capital pause. Open mode underscore capital which is in pipe out override. Return, call the member function seek off. It's a member function, so no qualify, and we don't need this arrow. Off type of SP. Here, Misco is constructing with braces. That's nice because it avoids being a C-style cast. I believe both of these are actually long. We just looked at this one. This is long. Pause type is stream pause. That's long. So they're literally the same type, actually. IO space begin and which. Okay, so that's all good. And then set buff returns on my stream buff pointer. KRT star S is LM star underscore capital buffer. Stream size N, stream size underscore capital count. It's an override. Oh, the standard forgot to say override here. But it did in the class definition, didn't it? Yeah, set buff override, so that's missing here. If somebody would like to file a editorial issue on CS Plus Draft, be my guest. Or a pull request, just add override there. Good first issue. Okay, equivalent to this arrow span member function. Let's make a std span of elem and brace. So he's using braces here. The buffer pointer directly, and then count is a stream size. That is a long. Span insists on taking size t, so static cast down to size t, and then return this. Briefly wondering about what happens if this is too big. for the size T, but the standard says effects equivalent to, so it does an implicit conversion, making it explicit is just as good. I don't think they thought about the case where stream size is 64-bit and the span is only 32-bit, and what if somebody sets above a really big value? I don't think there's anything for us to do there. And then we've got our exposition only data members that are private. Underscore capital mode, brace initializer, in pipe out, std span lm, underscore capital buff, brace brace. And we're at the end here. Okay. So we got through the buffer type. And I don't believe we're missing anything else. We've got the overridden virtual functions. I talked about the maintained data. We've got the non-member swap already. Oh, that's right down here. So we actually did get down there. Okay, looking good. So now it's just the iSpan stream, OSpan stream, and span stream, and then the tests. Okay, so I think we can call this a video review. It's been an hour and a half. I may review the rest of this offline, or we may be seeing this again next week, depending on how busy we are. We will see. Hopefully this was interesting. Are there any questions? I want to get to the here. Was there anything else in the chat? Let me switch over to the chat.
No, I don't believe so.
Okay.
It was mostly me shit posting, and yeah. Cameron and I had a brief discussion about the intent of this header being to replace the deprecated stir stream, which has been deprecated for 23 years now.
Yes, I would love to see stir stream be eliminated because it's so unusable. And this is definitely an important step towards that because the committee was uncomfortable with deprecating and removing something with no actual replacement. So, okay, thanks everybody for this code review. Attending this, I think we can stop the recording now. See you next time.
Thanks.